Hello everyone and welcome to Miss Online Session. Now in this online session we are going to cover implicit typing, object initialization syntax, anonymous objects, and delegates. And if we have time, I could go on to actions and functions, but we will see if we can get on time and do that during this online session. So, I hope that everyone is ready, so I could actually get started. Get your thinking caps on. It's gonna be a very fun ride. Okay, so let me get a couple of stuff out of my to-do list right now. First of all, I would like to talk about the implicit typing. Now, the implicit typing is very simple. If you define an integer I equals to 0. You could define it in another way. You could write in var j. I mean, I cannot write I, or you could, if you would like to, I can just call this I1 and I2, and let this 10, and let this be 10. Okay. Now, both of those are exactly the same thing. This is the same exact effect. If I go here, just to show you, right line I1 plus I2, okay? And if you look here, let's hope I can get some, let me see. I cannot get the definition on, can't I? Well, basically, anyway, if just the IntelliSense was just a little bit cooperative with me here, you would have seen that this I2 is defined as an integer. Now, what is exactly var? I wouldn't say that var is a data type, so do not mix it up with something else. It's not a data type. It's more like a hinting, you can think of it that way. That's more like a hinting to the compiler, telling the compiler, please figure out the value or the type, the type of the variable which I've defined based on whatever was after the equal sign. Okay? So, for example, I could define var my float as going to have 0.01f. And this is my float variable. Now, of course, it's not written there, so I'm going to just add to it my float. And yeah, again, it doesn't want to cooperate here. But basically, if this is my float, it detects it because there's a float variable here. If I take out this the f key, right now I have a double variable, which is my float is going to be immediately double. If I make this as 5, right now my float becomes an integer. Okay, so it's basically the var is just hinting the compiler to guess out the type of the variable which I'm defining based on what happens after the equality sign. So it works not only with numbers, it works as well with, for example, lists like these. Okay, so right now I have defined a new list, and this is exactly the same as this. Sorry. This line of code is identical in effect to this line of code. Okay, it is exactly the same. Now, please do not think that the var is some sort of a dynamic keyword, that at one point you could say the same list equals to 10. You cannot actually do that. This is one of the things that you have to understand, because a list is still, I mean, this LST, or let me like this LST is a list of integers. Okay? You have defined it that way at the beginning, and this is it. And it will stay that way. Okay, it will stay that way until the end of the program. Rule number 2, when it comes to implicit typing, is that you cannot say var I semicolon. Right now you are confusing the compiler because the compiler cannot infer or guess out what I is, because with this keyword you are trying to tell, okay, figure it out after the equality sign, figure out the type of I later on. And since you didn't provide what I is going to equal to, the compiler cannot, it's completely oblivious to what I is going to be. Okay, so this is what implicit typing is about. You have to actually assign something to a variable when it's implicit in question. Exactly. Yes, you cannot have, you can have something like this, but you cannot have something like that. You see, this is explicit typing, this is implicit typing. It has to be like this in order for it to work. Okay, so implicit, explicit. All right, so any questions regarding this part? This is what it's all about, implicit typing, by the way. There are two reasons, by the way, for it, and I will show you why. There are two reasons why this thing exists, and you could have something like this, by the way. Like people could type in. People use vars for easy reading. You could have a dictionary of tuple, of a tuple, of a string and an integer, and the second part of the tuple is going to be another tuple of a float and a double, for example. And I think I let me see here, closing this part, closing that part, and let me continue on. And here I'm going to have a value which is going to be another tuple, just for the kick of it. So a tuple of string and an integer. Close that. My crazy dictionary. Now don't ask me why would you have something like that. Well, I right now, Saleh, I'm explaining when to use it. Equals to new that. Now you see, imagine that you have such a line of code. I've been exaggerating here. This is more like a cartoonish way of showing this. This is a comical example. But let's say you have some sort of a definition that's as large as this. Would it be a lot easier if I just simply said this, and you don't have to type it twice? So yeah, there you go. So we could just simply say like this, and it will work, and it is going to be exactly identical to the previous example. Now there is another reason, which is much how can I say I mean, this is one of the reasons, like, it's not a good reason. I mean, you will not introduce a keyword just for that, but there is even a better, a stronger reason, which we're gonna come to in a second when we come into actually anonymous objects. But before I go there, I would like to show you the object initialization syntax first. So let's say I will put here a class person. I mean, I always like to separate my classes into separate files, but just to keep all the code in the same place so you can see everything. And here our famous victim is gonna have a string and an int age. By the way, the var, as far as I remember, in C++, they had auto, because implicit typing is already introduced as well in C++, C++11, by the way. So they have auto instead of var. And this object initialization syntax right now is already also defined in C++11 standard. So there are various ways of creating a person, by the way, to construct an object. First, the first one which could come to your mind is like, I will have a var person or var p equals p1 equals to new person, and then you say p1 dot name equals to, let me see here, I will grab the people from online, so Imad, sorry about that, man. p2 dot age, p1 dot age is gonna equals to, would you like to put any number, or 21, as you wish, sir. So, and we are good to go. Okay, so this is an object, this way of constructing it. Another way of constructing it is that you could, of course, if we have a, I mean, I'm putting here a default constructor just for you guys. So I'm gonna have here this dot name equals to nothing, and this dot age equals to 0. And you could have another constructor, of course, which is gonna have this string name and an int age, and then of course the usual stuff. So this dot name equals to name, and this dot age equals to age, and we are good to go. And then you could say, okay, I'm going to create a var p2 equals to new person, actually new person, and then you pass in, let's say, who is there, Salih is going to be, so to make some variation, and comma age, would you like any number, sir, or shall I improvise? Salih? Okay, as you wish, sir. 20. So, and there you go. This is a shorter way of writing it, right? Now, there is another way of constructing an object, which is like this. Var p3 equals to new person. You close the brackets, and then you open a new curly brackets. Right after the parentheses, if you hit the space key, you see it requires from you the properties. So right here, name is going to equals to, let's see who's online here. I think Almir, I see him here, comma, age equals to, thank you very much, Almir, for saving me the trouble of asking. And there you go. This is the third way of creating an object using the new object initialization syntax. All right. Now, in order for this to work, in order to get the object initialization syntax to work, you have to have a default constructor. If I comment this like so, Control K, see, right now you will get an error. Of course, I mean, I will get an error because I don't have a default constructor here, but let me even comment that. And as you can see here, it asks for it, does not contain a constructor that takes 0 arguments. So you have to have at least a default constructor so you could do this. All right, so let me Control KU and Control KU, and we are good to go. Now let's talk about why var exists. I mean this is equivalent to that, right? I mean, I could replace these vars with persons, and we are good to go. I mean, there is no difference in here. However, there is something which Microsoft introduced, which is called an anonymous object. Now, an anonymous object is it's just a simple object that you create just out of the thin air, an object of a class that doesn't exist. Now, I could do it like this. So var out obj out of thin air equals to new, open curly brackets, and then I could just define something like this. Crazy property equals to wow. Interesting equals to yes, and how much equals to 100. And now you created just an object out of the thin air. By the way, it's compilable, and I could actually print it out. Console.writeLine. And here I'm gonna print out object obj out of the thin air. Yeah, yeah, just so you can create attributes of this object like that. Yes, yes, all in one line immediately. So you see, Control F5. You see how it looks like? Crazy property equals to wow. Interesting equals to yes. How much equals to 100. And the coolest thing about it is this. So obj out of the thin air dot, and then you can access them. You see? By the way, they are read only as far as my knowledge goes. So you cannot do this. I think, as far as I remember, you cannot do this. It's just a read only. So you can just simply retrieve them. Okay. Now, now what happens behind the scene here is that the compiler goes ahead, reads this line of code, creates for you an anonymous type, and you could see it in the compiler. If you decompile the code of this program, well, let me see if I have JetBrains.peak, and let me see if I can in fact decompile and see this. You will have the name of this class is going to be like the compiler will generate a class for you, implement the toString function, override it. I mean, override the toString method. Create for you these methods, the getters and set, I mean the public properties and everything. Creates for you everything, and then I think console application is added 12, which is good, and then it compiles. I mean, and then you already get the program. Let me see here, and it's called like this: underscore underscore anonymous type and a certain ID. And then it defines what kind of variables in there. However, I mean, this is the yeah, as you can see here, it's not, I cannot get, it's really quite sad. I don't know why I cannot see the class. Ah, there you go. Here it is. Here it is. There you go, there's the class. You see? It generated for you an internal sealed class, a class which you cannot exist. Do you see it right now better, Imad? Okay, so as you can see here, it's a class, it is a sealed class created for you, you know, with a specific name, private read only, blah blah blah. And let me see here, can I no, I cannot see it without this part. Okay, and then it gives you only getters. Okay, and you construct them right here, and this is it. And this is how the override to string has been implemented for you. Override to equals and getting hash code. Everything has been just implemented for you, and you created just an object out of the thin air. Now, I wouldn't advise that you create or you use I mean, you could use anonymous objects in certain applications, but I mean, in certain problems. But do not make anonymous objects that in case you are planning to reuse them. Okay, this is some sort of an object that you can use once, and this is it, of some sort. And we're gonna see later why later on in the semester, once we get to link. Entity framework, ADO entity framework with link, so ADO, so link with entities, and we're gonna see how we can utilize the anonymous objects to its full extent. Okay, but for now, this is also another reason why var in fact exists. And as you can see here, the definition says like this: anonymous type A. Now remember, some people would say, okay, what if we go without var? Would we be able to do this? I don't know. I think if I write object, we are having the same thing. It will compile and run. And if I run this, you're going to get this normally. Nothing will happen because, again, if you remember, all classes that you create and every class and everything which exists in .NET Framework inherits from the object class, right? So right here, the problem with it is that I think you cannot access any of its properties anymore. And this is because you explicitly said that this is a type of an object. And the problem here is you cannot cast it back because you want to cast it to a type that you don't have. The type is being generated for you automatically, the type which is the class. You don't know how you're going to cast this back to its original form. So that's why you have var, which allows you to have in fact, using this anonymous, using this implicit typing, it can figure out for you that this is, yes, a type. It's actually a class, so it's actually a type that you can access its properties. You know, if you said object, as you saw, it will be just, okay, this is just a simple generic object. And if you would like to access its properties, you have to cast it into, you have to cast that object into its original class where it was created from. Okay. So this is a very important point that you understand. So this is how to create an anonymous object. And this is what anonymous object is about. Any questions regarding that matter? Guys, are you still with me here? All clear. Okay. So this is one of the main reasons, by the way, why Microsoft introduced var. I mean, of course, there could be other ones, but this is I think one of the most obvious ones. Okay. So now that I've got this out of the way, so we have got the implicit typing, object initialization syntax, which is this one, and we have got the new way of initializing an object. And we have introduced the anonymous object, yeah, okay, and we need to go for delegates right now. Okay. Now delegates is for those who are, I'll just erase this code, I don't need it anymore. For those who are familiar with C++, a delegate is just some sort of a function pointer. Like in C++, almost exactly like in C++, a function pointer. However, a delegate it packs inside itself more than just a mere function pointer. Okay, so for those who are still remembering C++, you're gonna see something like having an effect of a function pointer, which behaves that way. Okay. Now, let me show you what was in the books. I mean, right now, I think, of course, there will be other examples on the internet of describing delegates, how they work and everything. This is what I saw when I was reading several books long time ago, when first time I was reading about delegates. They had something like this. So they defined delegate, void my delegate. Okay. And as you can see here, a delegate, by the way, is a type that you can create an object out of. Okay, and once you define a delegate, if you would like to define what is it like, you have to define the signature of the function which you're going to point at. So imagine this: you are grabbing a whole method, like let's say like this. Or private, doesn't matter. Okay? So you could have something like this, and you can stuff this whole method into one variable and pass it. Okay? And this is what the delegates, and this is what the delegates are all about. Okay? The main thing is that the signature of the function or the method which you are pointing at has to match the signature of the delegate. So, if I'm going to point at this guy, this is a void method that doesn't take any parameters. So, if I'm going to use this delegate to point at this function, this delegate has to be void, and it doesn't take any parameters. So this delegate is completely legit for pointing at methods that are void and they don't take any parameters. Now, in books, they have something like this. Public void run the delegate, and it takes a delegate del, okay, and say del.invoke. Uh-oh. Sorry. My delegate del.invoke. And right here, you will have something like this. I could define it like my delegate equals to print something, and right here you say run. It's a static. I'm making it just private, just for fun, I mean for better design rather than nothing regarding the nothing regarding making this application running. All the functions could be even public. It doesn't matter. The main thing that they are static. Imad, yes, looks like function pointers from PR1. From PR1. Yes, exactly. And I'm gonna say here, I'm gonna pass in my deleg. All right. And if we run this program, it will print something, right? And honestly, this is what was in the books. And the problem is people didn't go expand beyond that, and then they said in these books they said, okay, this is the main idea of it. Let me show you how delegates work with events. And then they start pointing methods to running events, pointing at methods, and so on and so forth. And then you get this idea of delegates going. However, delegates they are much more how can I say, they can be used in a lot of other applications other than just events. And you could see it very clearly in link framework, for example. It's a very beautiful piece of syntax and how you can actually start using it. So many of you would be asking, like, why I just didn't go ahead. I mean, why on earth did I sit down, write 1, 2, and 2 lines of code just to call a simple method, right? You could have done something like this, which is the same question which I asked myself first time when I was reading it, you know, why I would do that. And in order to do that, in order to explain to you why would you even use such a feature, is giving you a concrete example. I will erase this part. I don't need it. I will, I have the insert key was pressed. I'll erase this part. Oh, before I do that, hang on a sec, sorry about that. There's a very important concept I have to hammer down. Here, I stuffed this method right in here. I passed this parameter, or this variable, right here as a parameter of this function. This method is being called, and del.invoke, it will invoke any method which is actually it's pointing at. There's one more thing. You could chain them. Honestly, I don't know about if you can do that in C++. I haven't investigated that. However, you could do something like this. Okay? And I could have deleg plus equals print something too. Now watch this. I have something and something too. It goes ahead, it's like adds them into a stack and goes ahead and invokes each one of them. Once you just simply call invoke, it will just simply invoke all the functions, all the methods which is actually pointing at. And you can see it a lot in Windows application programming. When you remember when you were creating a new Windows application, on button click, you see the button click event plus equals to system dot I don't know on button click event, and then takes the pointer to that method. If you want to, I can show it to you right now. Well, it doesn't matter. And if I it doesn't matter in any event. And if I go here in the form designer, you see this? This is exactly the same, almost exactly the same effect as this. Okay? You can start chaining them. You can start adding a lot of methods and just simply saying one invoke, and it just invokes 1, 2, 3, 4, 5, and so on and so forth. Okay? This is one of the features what you can do with the delegate. And I think you can remove one from the stack. Like, I think if I say deleg minus equals, I think, print something, I hope that I'm not mistaken, you should get something too, only. So you took out, you unsubscribed from one method and you just subscribed to only one. Okay? So this is how I just simply took out one delegate pointer and just simply pointed to another function. This is it. Now again, I mean, why would you do this? Let me just take this out and take this out, and well, I will leave this here. I mean, I will take this out as well. Let's say for a second that we have a function that looks like this, or a method that looks like this. So I have a list of integers. So I have a private static filter list of integers, filter more than 5, and right here I'm gonna take an input, so list of integers input, right? And right here you would say, okay, var lst, actually var result equals to new list of integers. From now on I'm gonna write vars, by the way, I will not write the full thing. And here I'm gonna say for each item in my input, I will say if the item is more than 5, please result.add item other, and there's just simply at the end return result. Right here I'm gonna have the normal one. This is a simple programming 101 kind of getting stuff from a list, filtering, like get me every item in the list that's more than 5. I think this is like even introduction to programming problem. So here I would say var input equals to new list of integers, and right here I'm saying input input.add, and I'll have 1, and let me add a couple of them. And right here I'm gonna have 5, 4, 6, 10, 20, 120, let it be 30. Okay, so we have got those, and at the end I will say for each item in my filter more than 5, which is going to take an input, I will say yeah, we are good to go. Console.writeLine item. So if I run this program, I'll get 6, 10, 120, 30. Okay, pretty easy, very clear, nothing fancy about it. And just for clarity reason, I will just simply put here var output equals to that, and I'll just simply loop over output, just to make it easier, or a little bit, less intense. Okay. Does anybody have any questions regarding this program, regarding this piece of method for now? Okay. Now imagine the following. Your boss comes at you and he says, okay, I would like not to filter only the stuff that are more than 5. I would like to filter the stuff that are more than 6 or 7, right? And at the end you say like, gee, what I can do, right? And then you can start thinking about it. If you are coming from very simple background in programming, you would do something like this: filter more than 7, right? Some people would do like this, you know, and then we'll have 7, right? And when we are good to go. Now, of course, this is kind of weird because we have a lot of numbers in our numbering system. It's infinite, so it's kind of stupid if you do this. So, for example, you would go ahead and say, aha, okay, it's fine. I could just simply pass in an integer number, and I will just simply compare against that number. So I'm going to simply say, if that item is larger than a certain number, right now I'm going to filter my list according to it, and I'm going to just simply say, call this filter list, because it's not more than or less than, or I mean more than a certain number. It's just a simple filter list more than, and there you go. Now what you would do here is just simply say, okay, filter list more than, and the input is going to give it, let's say 5, so because we wanted to seek more than 5, right? And right here, if I hit Control F5, we're going to get the same output, and I could right now do as my boss says, and I have all the numbers which I need. Now your boss comes at you again, and he asks you, okay, I would like to filter the list based on, I mean, whatever less than whatever a certain number, right? And then you would say, okay, now it's going to be tedious, because if you think about it, you have to create one method for more than, one method for less than, one method for equals, one method for not equals, one method for less than or equals, one method for more than or equals. So we have like six methods just to describe a small functionality. Now, how would you compress that into one? Now, of course, some people would do something like this. I will go ahead, create an enum, and I'll call this equality sign. And people here will say, okay, I will have more than, less than, more than or equals, less than or equals, and we're gonna have more than equals, less than equals, and equals, not equals. And I think I covered them all, right? 6, all of them are 6. We take input from the keyboard. Oh no, come on, man. This is, by the way, this is this was a really good joke. But what I wanted to say is, right now you are right now programmer A, the guy who's making the framework. Programmer B, he's actually going to use your methods and call them. That's the point of this whole beautiful story of an adventurous programmer on a road to victory and truth and whatever you would like to call it. Right now it's going to be an RPG game, I think. But okay. And now you would say, okay, I will have a static list of integers, and I'm going to have a filter list. And you're going to take a list of integers, and it's going to have an input. You're going to take an integer number. I'll make it smaller because I already made the number smaller, and I'm going to actually copy paste the code. And what else here? And then I'm going to have equality sign. Equality sign. And right now we're going to copy the same thing. We're going to have almost exactly the same thing. However, for every item, so I'm going to have here, I don't know, right now, I mean, I cannot, let me see here. I actually done this once during the class with the regular students. It occurred to me, but I forgot how would I solve this. Hang on a sec. So equality sign. We're gonna have a switch, in fact. So right here. So I'm gonna have it like this. Switch on equality sign, and then we get this. So if the equality sign is more than, then we just simply say if item is more than a number, result dot add the item, right? And then we grab this, we paste it here. It is less than, oopsie, less than. Here you're gonna have more than or equals. Here you're gonna have less than or equals. Opa, sorry, I forgot. I think I forgot. So more than, less than or equals. And sorry, less than or equals equals. And in fact I would even make this as default, but doesn't matter, it doesn't equal. Default break, and I don't care. Okay, sorry when you have thanks Imad for the tip. Now as you can see here, this is a very long, very long, ugly method. And of course if you would like to use this, I would take this out, filter list, and right here it will take 3 requirements. I'll give it the input, comma. I will give it the number, which was more than 5, right? And equality sign dot more than. You see? Right now we are growing in terms of thinking, by the way. I'm just right now, you know, this is like some sort of an iterative approach to the problem. How we can refine and refine and refine. Now, of course, this is more like a downgrade, but anyway, you see? Now, if I say equals, right now we're going to have only 5. You see? And of course, it's kind of cool. I mean, you get this kind of feature. However, it's not enough. This is not good enough. We need a better code. We need a smarter code to do things. Now, here it comes the delegates part. If you can see here, if you notice throughout our problems here, we are all the time trying to break into right here and change that piece of code, either for reasons that you cannot access that code by hand, or you really need to make this code, this part, generic as generic enough so people can use this for many other purposes other than just simply having less than 5, more than 5, and so on and so forth. So I would go ahead and define my delegate. And since I'm trying to get here an if statement to work, and I'm trying to break right in here, an if statement resolves to Boolean, is it? Is it either true or false? Because this is what it actually checks. Either a certain statement is true or false. So whatever method I'm going to stick in here or push in the middle here is going to be bool. And I'm going to call this predicate. And it takes an integer number. Okay? Now, I mean, right now maybe it's a little bit not clear, but you will see, you'll have the epiphany moment in a second. So right here I'm going to have filter list. So I'm going to copy actually the whole thing like this. However, I will not have this nor that. I will have my predicate or checker. And in fact, I'm going to copy this code. And right here, instead of having if item is larger than or less than a certain number, I will pass in here checker and I will pass the item dot actually dot invoke, so you can see it in its true form. Okay, and this is it. Now how can we utilize this thing? If I go over here, by the way, filter list with delegates, or with delegate, because we have only one delegate in there. And right here I'm going to have a small method here. I'm going to call this a static bool check if less than 5. And right here it takes an integer value, whatever, or variable. And right here I'm going to return if a variable is less than 5. Okay? I'm gonna go ahead and define another var output 2 equals to filter list with delegate, passing it the input and giving it the function or the function pointer. I mean, I'm gonna actually not function pointer. I'm gonna actually point to a function. So I'm gonna grab check if less than 5 semicolon. For each output, for each item in output 2, just print me the output. So right here I'm trying to check if less than 5. So if I control F5, I'm getting all the numbers which are less than 5, which are 1 and 4. You see? Now let's think what's happening in here for a second. So I made a list, I made a method that takes an input and takes a pointer to a method. Okay? And what's going on here is I'm defining a temporary list for each and every item on the list, and please, for every item, please check for me if this item satisfying a certain condition. So I use delegates to break into right here, inject my code. I could inject like a huge piece of code right here. You see how flexible it is? So, and check if a certain number is less or more or equals to a certain number. Okay, or check if the item is less than or equals to a certain number. And if it is true, then add it to the result. If it is not, then just gonna return an empty result, and this is it. And right now I could have even a better way of doing it. I could just simply say, okay, give me everything which is larger than 5. And I get everything larger than 5 without even touching this part of the code. Right now you get more elegant solution, much cleaner, actually much cleaner solution than this. You see, I've reduced my parameters even of the function to this, and that's it. I don't need to pass in the number nor creating my own enum just to get, you know, a certain condition satisfying and working. This is much more efficient, much faster, so, and much cleaner, more convincing. Okay? So this is what delegates are almost all about. Almost. Okay, this is how you can harness, how you can use their power. Yes, indeed. Yes, indeed. Very flexible. Okay. Let me see here. Now, the problem with this list, the problem with this filter, okay, it's really restricted to integers. Now your boss comes at you and he says, I would like to filter list of people, I would like to filter list of products, or I would like to filter a list of doubles. Now the amount of classes that you have to, the amount of methods that you have to create for each class is huge. And you really don't want to type every time a filter list with a delegate that satisfies a certain data type. Okay, so what I can do here is writing a generic function. Now how can we write a generic function? Very easy. You define a list, it accepts a list of t, Actually, it returns a list of t. Filter list generic, and you have to type t right here. List of t, which is going to be the input, and predicate. And right now I have to define my own predicate, which is going to be, it has to be generic one. So right here, I'm going to define another predicate, which is bool, but it has to be t and t, right? So I'm referring to, I'm going to point to a method that is completely generic. And right here, I'm going to copy and paste this code. Oops, right here. And of course, it's not a list of integers, it's a list of t. Now, why I put t here? This is the syntax of defining a generic method. So once I define a method, and say, for example, I'm passing a list of integers, boom, everything becomes an integer. If I define a list of people, boom, everything changes to people. And I will show it to you in a second. T is the type, yes, Imad. T is the type which is going to be replaced later with whatever type in the compile time when we start, or in the code. So here's the effect of what you could do. I will add, you know, before I add anything, I will have var output 3 equals to filter list generic, and as you can see here, I get these angular brackets of some sort, and right here I could say integer, and as you can see here, everything became an integer, exactly like templates. Yes, Saleh, exactly like templates. If I have here double, oopsie, double, everything becomes a double, you see? And right here I'm going to have int, and I'm here going to pass in the input, comma, and I'm going to point to the same method because, again, it accepts only a method, a predicate, which takes an integer. So it accepts only a method of a signature which takes an integer. If I say for each var output 3, I get the same result. Now watch this. If I define a class really quick here, so public employee, and let's say that this employee has a name, and a public decimal or public double, let it be, actually it should be decimal, but it doesn't matter, salary. You always want to work with decimals when it comes to money, by the way, in C#, very important. And right here, I'm going to have a var imp list equals to new list of employee, and here I'm going to have an imp imp list dot add, and right here I'm going to pass in a new employee, and using the object initialization syntax which we learned, I'm going to have again the same guys. So I'm going to have here Imad, sorry about that, Imad, and then salary. Would you have a salary in mind, Imad? Would you like to have some number? Make it like 1,700. As you wish, sir. Okay, let's go ahead and, and let me close this. Okay, and take this out, and okay. So let's say, sorry about that, Control C. We have a couple more. So Salih, do you have any number in mind? 2,000. Greedy. What do we have? Whom do we have here? Almir, I think. And Almir, how much would you like to have? Well, oh, Almir, very humble, very humble, I say. So this is what you like to have. Okay, cool. Now, if I would like to filter this list, I cannot filter this list and say check if less than an integer variable. Now I have to define another method to filter them. However, if you look at the var output 4 equals to filter list generic, right now you define here an employee. Right here it accepts as an input, which is, the imp list, sorry, which is an employee list, and then it would like to point to a method that takes an employee object as its parameter and its generic, which is t. So it takes an employee as a parameter and returns bool. Sorry about that. I mixed up everything. So static bool. Let's say I would like to get everybody who's having salary below 2,000. So I would like just give them a raise. So I would say, okay, bool get imps for raise, and it takes an employee object imp. Right now it's a little bit more or less a real world scenario. And right here I'm gonna say and return if the imp having a salary less than 2,000. For everyone who has a salary less than 2,000, please return to me. And right here, I'm gonna paste that there, and I say, give me an output 4. Do not forget the magnificent famous semicolon, and we are good to go. So let me hit Control F5, and of course I get those employees in there. I could, all right. String format, employee name 0, salary equals to 1, comma, and right here I'm gonna have this dot name, and this dot salary, semicolon, and Control 5. So right now I have employee name Imad who's having a salary 1,700, and I say employee name Almir who have a salary 1,400. Okay. So as you can see here, I could generically filter the list, either a list of integers or even a list of employees, all using the same list. Now there's one more trick. This is explicit typing. This is implicit typing. Instead of saying checker.invoke, you could have it like this. And it is exactly the same effect. You see? So there you go. This is what you can do with delegates. And this is what you can do with writing generic methods like these. Now we could make these methods even better and better. Right now, all this code which you have typed is completely useless. Right now you can ship this. Okay? Sorry, not this one. This one. You see? You have only one method that does everything for you. Less than, more than, equals, not equals. Filtering based on any kind of condition. You could have your own algorithm of filtering people like cross-referencing them. Let's say I would like to get all people that are taller than, I don't know, 170 centimeters, but they have this age and they have this type and they have this and this and that. I mean, you can have a complicated algorithm as an if statement just to filter a simple list of people. Like you would like to get a certain amount of people with a certain direction or backgrounds, and this is what it's all about. Okay, and as you can see, as we're gonna probably cover in the next lesson, I think in Monday, I would say, because I think it could be, I think it's a little bit enough for you guys for today. Why it is even kind of stupid to write these guys repetitively. Imagine that you are writing a huge amount of methods which are only utilized once. You see, I mean, I'm utilizing this method once and I'm utilizing it here. I'm not going to use it again. Just to show you, before I go ahead and conclude this class, that you could, in fact, write the whole method in one line and embed it inside here. I could say E goes to E dot salary is larger than 1,400. Give me everyone who's having a salary larger than 1,400. I've right now defined an anonymous method using lambda. This is called a lambda expression. This maps to this. Whatever comes here maps to here. So in fact, if you see the compiler generated code, let me recompile this and let me, can I refresh this? I think. I don't know if I program if I just can find it, actually I would be happy to. There you go. You see, this is the generated code. And where's our line? Right. Let's do. Okay. I cannot actually find it. I cannot see it anymore. Well, basically, okay. Do you remember the employee E which I have defined? I mean, I cannot see it right now somehow. This is what the compiler does for you. It just makes a method out of it. Okay? So this is what your thing is getting expanded to. You see? And whatever comes, it reads like this. E, this sign it says goes to, and then the rest of the statement. I will describe in the next Monday in detail what is the meaning of this, or how to write several methods that have different looks to them. What if a certain method, anonymous method that takes 2 parameters? What if I have a multi-line code instead of just only a single line, and so on and so forth. And as you can see here, right now I don't even need those. I just simply write a method all in one line of code, and this is it. You see? So right now all this code could be compressed into this method and whatever input we have and this line of code. And this is it. Alright? This is what I wanted to cover with you today or tonight. Do you guys have any questions regarding what we have covered up until now? Or you are stunned by the beauty of the code? Oh, okay. All clear. All right. Okay, since there are no, or are there any further questions? No? Before I stop the recording? Okay. Alright, so I shall stop, since there are no further questions, I just simply shall stop recording. So thanks a lot for your attention, and then see you next time.